Armillaria is a genus of parasitic fungi that includes the Amelia species known as honey fungi that live on trees and woody shrubs. It includes about 10 species formerly categorized summarily as Amelia. Armillarias are long-lived and form some of the largest living organisms in the world. The largest known organism of the species Armillaria solidipes covers more than 3.4 square miles (8.8 square kilometers) in Oregon's Malheur National Forest and is more than 2,400 years old. Some species of Armillaria display bioluminescence, resulting in foxfire. Armillaria can be a destructive forest pathogen. It causes white rot, root disease, see plant pathology section, of forests, which distinguishes it from Trichiloma, a mycorrhizal, non-parasitic, genus. Because Armillaria is a facultative saprophyte, it also feeds on dead plant material, allowing it to kill its host, unlike parasites that must moderate their growth to avoid host death. In the Canadian prairies, particularly Manitoba, Armillaria is referred to often as pidpenki, Ukrainian, pidpenki meaning beneath the stump, in Ukrainian. Description: the basidiocarp reproductive structure of the fungus is a mushroom that grows on wood, typically in small dense clumps or tufts. Their caps, mushroom tops, are typically yellow-brown, somewhat sticky to touch when moist, and, depending on age, may range in shape from conical to convex to depressed in the center. The stiped stalk may or may not have a ring. All Armillaria species have a white spore print and none have a volva cup at base. Compare Amanita. Similar species include Foliota spp, which also grow in cespitous, mat-like clusters on wood and fruit in the fall. Foliota spp are separated from Armillaria by its yellowish to greenish yellow tone and a dark brown to gray-brown spore print. Mushroom hunters need to be wary of Galerina spp, which can grow side by side with Armillaria spp, on wood. Galerina have a dark brown spore print and are deadly poisonous, alpha-amanitin, see, mushroom poisoning. Plant pathology. Honey fungus is a white rot fungus, which is a pathogenic organism that affects trees, shrubs, woody climbers and, rarely, woody herbaceous perennial plants. Honey fungus can grow on living, decaying, and dead plant material. Honey fungus spreads from living trees, dead and live roots and stumps by means of reddish-brown to black rhizomorphs, root-like structures, at the rate of approximately 1 meter a year, but infection by root contact is possible. Infection by spores is rare. Rhizomorphs grow close to the soil surface, in the top 20 centimeters, and invade new roots, or the root collar, where the roots meet the stem, of plants. An infected tree will die once the fungus has girdled it, or when significant root damage has occurred. This can happen rapidly, or may take several years. Infected plants will deteriorate, although may exhibit prolific flower or fruit production shortly before death. Initial symptoms of honey fungus infection include dieback or shortage of leaves in spring. Rhizomorphs appear under the bark and around the tree, and mushrooms grow in clusters from the infected plant in autumn and die back after the first frost. However, these symptoms and signs do not necessarily mean that the pathogenic strains of honey fungus are the cause, so other identification methods are advised before diagnosis. Thin sheets of cream-colored mycelium beneath the bark at the base of the trunk or stem indicated that honey fungus is likely the pathogen. It will give off a strong mushroom scent and the mushrooms sometimes extend upward. On conifers, honey fungus often exudes a gum or resin from cracks in the bark. The linkage of morphological, genetic, and molecular characters of Armillaria over the past few decades has led to the recognition of intersterile groups designated as biological species. Data from such studies, especially those using molecular diagnostic tools, have removed much uncertainty for mycologists and forest pathologists. New questions remain unanswered regarding the phylogeny of North American Armillaria species and their relationships to their European counterparts, particularly within the Armillaria-Melia complex. Some data suggest that North American and European A. gallica isolates are not monophyletic. Although North American and European isolates of A. gallica may be interfertile, some North American isolates of A. gallica are more closely related to the North American taxon A. calvescens than to European isolates of A. gallica. The increase in genetic divergence has not necessarily barred intersterility between isolated populations of A. gallica. Although the relationships among some groups in the genus seem clearer, the investigation of geographically diverse isolates has revealed that the relationship between some North American species is still unclear. Hughes et al. 2003. Intersterile species of Armillaria occurring in North America. North American biological species equals NABs were listed by Mallet 1992. I. Armillaria ostii, Roman, Herinck 2 Armillaria gemina Bayrabe and Deschiraux 3 Armillaria calvescens Bayrabe and Deschiraux v. Armillaria sinopina Bayrabe and Deschiraux v. Armillaria melia, Vol. Fries, Kummer 7 Armillaria gallica, Marksmuller and Roman, X Armillaria nabsnona T.J. Volk and Birds, 1996, X Armillaria altimontana Brazzi, B. Ortiz, Bannock and D.L. Lindner 2012 and 11 taxonomically undescribed nabs I, V, 7, X, and 11 have been found in British Columbia, I, 3, V have been found in the Prairie Provinces, with I and V occurring in both the boreal and subalpine regions, I, 3, V, and 7 have been found in Ontario, and I, 2, 3, V, and V have been found in Quebec. Armillaria ostii is the species most commonly found in all Canadian provinces surveyed, Mallet 1990. Armillaria root rot occurs in the Northwest Territories, and was identified on white spruce at Pine Point on Great Slave Lake prior to NAB's findings. Edibility honey fungus are regarded in Ukraine, Russia, Poland, Germany and other European countries as one of the best wild mushrooms. They are commonly ranked above morels and chanterelles and only the cep porcini is more highly prized. However, honey fungus must be thoroughly cooked as they are mildly poisonous raw. One of the 4 UK species can cause sickness when ingested with alcohol. For those unfamiliar with the species, it is advisable not to drink alcohol for 12 hours before and 24 hours after eating this mushroom to avoid any possible nausea and vomiting. However, if these rules are followed, this variety of mushroom is a delicacy with a distinctive mushroomy and nutty flavor. Reference texts for identification are Collins' Complete British Mushrooms and Toadstools for the variety of field pictures in it, and Roger Phillips' Mushrooms for the quality of his out-of-field pictures and descriptions. Norway used to consider honey fungus edible, but because the health department is moving away from parboiling, they are now considered poisonous. Potential hosts include conifers and various monocotyledonous and dicotyledonous trees, shrubs, and herbaceous species, ranging from asparagus and strawberry to large forest trees. Patton and Vasquez Bravo 1967. Armillaria root rot enters hosts through the roots. In Alberta, 75% of trap logs, Mallet and Hiratsuka 1985, inserted into the soil between planted spruce became infected with the distinctive white mycelium of Armillaria within 1 year. Of the infestations, 12% were A. ostii, and 88% were A. sinopina, Blennis et al., 1995. Reviews of the biology, diversity, pathology, and control of Armillaria in Fox 2000 are useful. See also: Bioluminescence, Foxfire, List of Armillaria species. References